Well, hello. Today we are going to be starting in on finance with this chapter. And our finance chapter is going to incorporate a lot of different things. We're going to start off today just by looking at percentages and changing between decimals and percents and looking at some percent problems. But through the course of this whole unit, we're going to be looking at simple interest, at compound interest. We'll explore some credit cards, buying a house. We're going to get you saved up for retirement. Basically, your entire life. We're going to stop just short of funeral preparations. So we've got a lot to do. Might as well get started, I guess. So today, specifically, we're going to be converting decimals, fractions, and percents. Okay. Now, when you do these, you're probably going to want to use a calculator. You have access to a calculator, and at least in my class. So I would use a calculator. You have a calculator on your phone. You have a calculator everywhere. So let's use calculators. Now, when you want to change a fraction to a percent, if you have something like 67 hundredths, you would just put that in your calculator, and you would actually put the numerator in first, and then your divided button, and then 100. Now, what you would get back out is you would get this as 0.67. So that's what your calculator would say. And then after that, it says multiply the decimal by 100. Okay, well that just means to move the decimal over 2 places. And so that will turn this into regular old 67. The last part of this says add a percent sign. So we would do that. So 67 over 100 is actually just 67%. If you do this with 11/20ths, you would push in the calculator. You would actually use 11, and then you would hit the divided by button, and then 20. And that will come out to be 0.55. Now the next thing we would do is you'd multiply that by 100. In other words, you move the decimal 2 places to the right. This turns it into regular 55. And then you add a percent sign. Now remember, this percent, this actually is more like a compound word almost. Like you have the per and you have cent. That means for each 100. Right? 55 out of every 100, or 67 out of every 100. That's what a percent means. Over here we have 15/16, and you can do this on the calculator. You can do some long division. What it's going to get you is 0.9375. Remember, we move our decimal 2 places, 1, 2, so that will turn this into 93.75%. And there we're done. Just like that. Okay. Let's look at another one here that may be a little bit different. Okay. Let's take. What if you have 1, 2 over? I'm just making this up as we go now. 12 divided by 5. And if you put that in your calculator, you're going to get 2.4. Now 2.4. You still got to go through the same thing. This is not 2.4%. The mistake that a lot of people might make with this is they might just say like, oh, that's 2.4%. They actually forget about this part here. You got to multiply the decimal by 100. Okay, so 2.4, what we would do is we multiply by 100. In other words, you move the decimal 2 places. Look, there's not something over here. So we put a placeholding 0 in. And then what you get is 240%. Yes, it is okay to have a number larger than 100. Okay? So just kind of keep that in mind. I just wanted to do one of those because sometimes those slip through and people don't realize that you can have percentages larger than 100. You always got to move the decimal 2 places to the right when you're converting a decimal to a percent. Okay. All right, well, that's the next thing actually is we started out with converting fractions to percents. And this one says convert decimals to percents. Well, if you have a decimal, shoot, we're already halfway there, right? Just like what we were doing, except you don't even have to put it in the calculator. All you do is you're going to move this over 1, 2 places, right? Because you're multiplying the decimal by 100. This will turn into 14%. Over here for this next one, you multiply the decimal by 100. Percent means for each 100 or for every 100. per 100. So we move it over 2 places, and then that's going to get us 89.3%. And the last one that I got here, when I move this over 2 places, I multiply it by 100, and then I get 76.25%. Okay. Let's do just a couple more down here, just for kicks and giggles, because it's good to practice. So I'm going to put 3 more up here. How about we do 0.51, 1.3, and 0.0007, not 007, 0007. Okay, try changing each of these into percents. The first one should be very easy. These other two we haven't quite done, but I think you can do it. So pause it, try it, and let's do it together now. So the first thing that we're going to do here is look, multiply decimal by 100. In other words, move the decimal over 2 places. This turns into 51%, and we're done. That one you should have definitely got. This next one, we move the decimal over 2 places because we got to multiply by 100. So I would go 1, 2, I guess. Okay. So my answer then would be 130%. There's a case where our percent is more than 100. Okay. The next one, multiply the decimal by 100. That means move it over 1, 2 places to right there. Now, this actually is the answer. 0.07%. Sometimes people get all hung up on this and they say, oh, well, I must have to move it over 2 more places. No, you move it 2 places because it's percent per 100. Move it over 2 places and then you're done. You write what you have, slap a percent sign on the end. Okay. One last one I just want to throw out here. What about if I had a number like 6 and I said, change this to a percent? Well, think about it for a second. Where would the decimal be? You'd say, well, there isn't one. Well, I know, I don't see one here, but I could write one. I could put a decimal right here. It'd be like 6. Look, 6.0. That's pretty much the same thing. I mean, it has a little more precision to it, I guess. But now, multiply a decimal by 100. So 1, 2 places. This would become 600%. So just a regular old number like 4 would actually become 400%. Just kind of keep those in mind. Those are a little bit tricky sometimes. Okay, the last kind then is converting percents to decimals. It's going back the other way. In this case, like I said, we're going the other way. We're going to do the opposite. We're going to divide the number by 100. Look, this 35% quite literally means 35 per 100. That's really what it means. Okay, that's what the percent sign means. But it's very simple to do. You just move the decimal 2 places. 35%, I would think of it like this, 35 point. And then I move the decimal 1, 2 places. That's 0.35. And it says remove the percent sign. Done. 35% is the same thing as 0.35. Forward or backwards, it doesn't matter. It's the same thing. The next one here, divide by 100. That means move the decimal 2 places to the left. I get 0.698. No percent sign. Remember, you move the percent. So these two are equivalent. They mean the same amount. They're written in different ways, but they mean the same amount. This last one here, 0.5%. So what this refers to, a half, let's first change that to a decimal. If I change that to a decimal, a half is just 0.5. So now I have 0.5%. Divide by 100. That means move the decimal 2 places to the left. 1, 2. So I get 0.005, and then you take the percent sign off. And we're done. Okay, so now that we've done some examples of going back and forth between fractions and decimals and percents, which you should have done in previous classes. Like this probably isn't the first time you've seen this. And if you need some more in depth, I would really suggest you finding some other videos somewhere about that, because this is stuff that you've done in plenty of other math classes as well. This is kind of a review, and hopefully that you remember that. Let's get started on some actual word problems now. All right, a question of the week at one point said, when is someone old? You know, if you ask like fifth graders, hey, how old is someone who's old? You'd probably get a lot of people be like, 27 is old. And, you know, if you ask people who are 27, hey, how old is old? They'd be like, oh man, probably like 45. That's old. And you ask people who are 45, they'd be like, man, 80. 80's old. And then if you ask 80-year-olds, hey, how old is old? They'd probably be like, I was old a long time ago. I don't know. But anyways, out of the sorry, I just wasted 40 seconds of your life, and I apologize. Out of the 3,496 people who responded, 1,017 said age 80 is old. So what we're going to do here is we're going to take the part that we want, or the part that we got, so that's 1,017, and we divide it by the total, the 3,496, right? This is part, and this is the whole, right? The whole amount. The part that said yes divided by the whole amount. And if you do that on your calculator, you're going to get 0.2909, and then we just multiply by 100. So that will turn this into 29.09%. Now, for me, I'm not super picky about how many decimals you go out to. You go out to what you think is appropriate. Just make sure that whenever you're doing homework, that you do round to the appropriate decimal place, because if you're doing some online work, it will count it wrong. If it says round to the nearest hundredth of a percent, well, we did that. If it said round to the nearest tenth of a percent, that would be 29.1%. If it said round to the nearest percent, that would be 29%. This one doesn't say, so you can just use your judgment. Okay, let's keep going. Let's learn about some cherries. According to the U.S. Department of Agriculture, Michigan produces a ton of cherries, right? 244 million in the whole country, pounds, and Michigan did 190 million of those. Now, this was something I actually knew because I grew up just south of Michigan, and I knew that Michigan has a lot of cherries. But this says, determine the percent of cherries produced in each state: Michigan, Utah, Washington, and all other states combined. Okay, so what we're going to do first is we'll just take the amount that we had, like the pounds, divided by the total. Now, you don't have to worry about millions. I know it was 190 million, and that's okay, because look, 190 million divided by 244 million, these labels actually just end up dividing each other out, and they cancel. That's how we're able to write our answer as a percent, and we don't have to say like 77.9 million percent. That just wouldn't really make sense in this problem. Okay, so we divide those, we get a decimal of 0.7786, and then we move the decimal over 2 places. That's how I get 77. You could say it is 77.86%. I chose to round to the nearest tenth here. Okay. So Utah had 19 million over 244. That's 0.0778. We take that times 100, and I get about 7.8%. For Washington said they had 18 million pounds, and that's a number that's very close to the other one. That will turn into 7.4 about, right? Because we move it over 2 places, I get 7.37, and here I just decided to round everything to the nearest tenth. All other states combined, let's get a new color here, we get 17 out of 244. That's 0.066696. Dang, that's a lot of sixes. And then when you move this over, we get over to here. That's 6.6. Well, I guess that would round up to 7 there, wouldn't it? So about 6.7% is what I got. And if you wanted to round everything to the nearest percent, you probably could do that as well. Okay. And the thing is, if you go through and add all these up, you see that they don't actually add up to be 100. I think these all add up to be 99.8 in total. And that's okay, because we're just rounding. I guess I better plug something in here. We're just rounding, and that's all right. So it's fine. Don't get too concerned with that. Okay. All right, the next thing we're going to look at is percent change, and this is one of the things that a lot of people really do mess up. Whenever you talk about the percent increase or percent decrease, here's a nice little formula. It's the amount in the latest period divided by the time before that, and then minus that. So you're looking for the change divided by the amount in the previous period. So notice here that this and this are the same number. You just got to figure out the number that you have right now minus the original amount divided by the original. Now, I actually prefer to think of it as triangle over original. And you're like, wait, triangle? What? This is a small, sure, it's a triangle. It's also a small letter delta. And delta, a Greek delta, means change. You use it in a lot of the science classes. It just means change divided by original amount. Now, this change can be positive or negative. It just depends. It's okay to have a larger number on back. It just means that you have a negative percent change. You're going to take a smaller number minus a bigger number. Okay? You just need to make sure to say whether it's an increase or a decrease. Let's take a look at where this might come into play here. In 2005, I live here in Arizona. I actually just missed the World Series that you guys had. I moved out here actually in 2005. So that's one of the reasons I bring this up. But the D-backs had the most improved record for wins, because in 2004 they were awful. They only won 51 games. And then in 2005, they won 77 games. Find the percent increase. The percent increase in the number of wins. So here's what we're going to do. We're going to take the change in their win total. The change, we would do that by saying 77 minus 55, and then we're going to divide that by the original amount. So that's 55. Notice that these back-end numbers, these are the same. Okay? So you have the current number minus the old number divided by the old number. All right? Gotta pay attention to that. We know that they won more games. And if they won more games, it should make sense that we are going to then have a positive result. And if you get these switched up, you're going to end up having a negative result. You're going to have a bad time. So we're going to take wait, why do I have 55 here? I know you guys were all wondering that. I'm glad that we caught that. Let's get that cleared up right here. There. 50, how about 51? 51. Okay. There we go. 77 minus 51 divided by 51. So when you do this, you're going to come out with 26 out of 51. That is about 0.5098. Then remember, to change that to a percent, we're going to move this over 2 places. So this becomes 50.98, which, you know what, that's about 51% increase. Notice that I wrote out increase after this. Yes, you have to put that. Because if you just say 51%, then I don't know if it's an increase or a decrease. Did they only win 51% of the games they won the previous year? I don't know. Okay. How are your stocks doing? 51%? Well, if it's 51% gain, that's awesome. If you only have 51% left, that's bad. So it's very important, this idea of saying whether it's an increase or decrease. Please make sure you're doing that. Okay. All right. Why don't we stick with our Arizona teams here, and let's go ahead and look at the Cardinals. Now, in 2015, they were awesome. They won 13 games. That was fantastic. But then in 2016, they had some quarterback issues. They only won 7 games. Find the percent decrease. Look, I even tell you it's a percent decrease. You should have like this negative number as you're working through things. So see if you can do this. Remember, it's change over original amount. Okay, let's do it. So I see that the original amount of games was 13, right? And so if the original's down here, I would put 13 there. And I also know that the back end of these two are the same. So it must look like this. We lost 6 more games than we did the year before. I'm on the team, right? And so we'll divide that by that. So remember, we do change divided by the original amount, like what you're starting with. So we get negative 6 divided by 13. Put that in your calculator, and you're going to get 0.4615. Then we multiply by 100. So that's going to move this decimal 2 places, and this will turn into 46.15%. Now, if you just box this, so help me, I'm going to be so mad because we're not done. Look, I know this is going down. So I will say this is about a 46% decrease. I need to make sure to label it. 46% decrease in the number of wins. Okay. Cool. Why don't you guys go ahead and try this one as well? Here's another one to try. It's a little bit tricky. Please pay close attention to the years on what the original amount is. Okay. Notice I just tell you it's a percent change, so I don't tell you if it's an increase or decrease, so please read it closely. Good idea to pause the video and try. If all you ever do is watch me do it, you're not gonna do very well. You need to challenge yourself and make sure that you're trying, and you pause the video, you work ahead. If you get it wrong, so what? Scratch it out, fix it. Okay, but make sure you're doing this as we embark on these videos. Please pause the video from time to time and work ahead. Okay, let's get going here. There were approximately 15.7 million labor unions in 2005, right? 15.7 in 2005, and there were 16.3 million in 2001. So, which is the original amount? Well, the one that is much older, right? The one from 2001, 16.3 million. So I know that's going to go down here. And I also know that 16.3 it goes on the back end because these stack up on top of each other. That must mean my 15.7 is right here at the start, right? I also know that because like if they started at 16.3, we went down to 15.7, I should have some kind of a negative amount. And I do. I get negative 0.6 divided by 16.3. That's negative 0.03688. Then we'll move that decimal 2 places, and I get 3.7% decrease. Notice that I do not need to put that negative out here because that negative is taken care of by the word decrease. Okay, right on. Let's keep going. This is a lot of times these problems are counted differently, but they're really the same. A percent markup or a markdown. If you're in the store, if you're a retailer, then you want to know how much you can mark up your inventory and to make money. So that's very important to have that understanding. If you buy something for $5 and you sell it for $3, that's probably not a good business model. I mean, I guess it depends on what you're doing, but so notice that what we've got here, I would want to stress this, dealer cost and dealer cost. Look at that. Those two are the same numbers, just like when we did it a little bit ago. We have the selling price minus the dealer cost. So this will end up ultimately being the profit if you make money, or the loss if you end up losing money. And then you would be dividing it by how much the dealer paid for it. Okay? All right. Let's take a look at something here. Howell's Hardware store pays $48.76 for some glass fireplace screens. They sell them for $79.88. Ooh, that's a nice little markup, right? If he could sell a whole bunch of those, he's making like $30 per screen. On sale, they sell them for $69.99 though. Determine the percent markup on the regular price. Ooh, the regular price. That's the one I have underlined right here. So here's what we got. We've got, we know that there's going to be an increase here. And the how much the dealer pays, that's what goes on bottom. So I would put 48.76 on bottom, and I'll go ahead and put 48.76 over here on the back end, because I know that those two numbers stack right on top of each other anytime I'm doing a percent change. 79.88 and then minus. Sweet. Right on. Here we go. When we do this, you're going to do this minus this, and then divide it by 48.76. Let me show you a common mistake that sometimes when people do this, they end up getting the answer 78.88. Okay? And what happens is if you put this in the calculator without using parentheses or without hitting enter, if you just do this wrong and you put it in the calculator 79.88 minus 48.76 divided by 48.76, your calculator is going to do PEMDAS. It's going to do order of operations. And so it sees the division sign, and it's going to do this first, and it's going to say 48.76 divided by 48.76 is 1. 79.88 minus 1 is 78.88. So you've got to watch out for that. If you are going to put this in your calculator all in one line, then the way that you have to do that is you have to put the top, we put the numerator in parentheses. That will cause your calculator to do this first, and you'll get 0.6382, which then becomes 63.82% markup. Or you can say increase. For me, I don't care. You can say markup, whatever. Now, what about when Hal decides to put it on sale? Is he still making money? Yeah, he is. So let's go ahead and take a look though at his percent. So instead of 79.88, they're going to just be selling them for 69.99. Everything else is the same, 48.76 and then 48.76. Right? The dealer cost doesn't change, only how much he's selling it for. Okay. So you do all that, you should end up with a 43.54% increase or markup. Okay. Make sure that you don't get sloppy like I do and forget decimals. Those are pretty important. Okay. Why don't you try it? This one's a little bit different. But at the end of the year, people go through and they try to discount things. They say, whenever, like in February or March, everyone's already bought their calendars. And so now these companies are just trying to recoup whatever losses they can. And so even though they paid $5, CB Green's cost is $5, and they're going to ultimately sell them for $4. Yes, they're taking a loss. But they're only losing $1 per calendar now if they can sell them. Listen, if they don't sell any of these calendars, then they're going to be losing $5 per calendar. So a lot of times these companies they'll discount things just to try to get back any money that they can on some of these. Okay, so think about it like this. Remember, we're gonna do the dealer costs that goes on bottom. Dealer cost goes back here because those two are the same. And we also have the selling price. So here's what this looks like. The selling price here is $4. The dealer cost is $5, and we'll divide that by 5. I get negative 1 over 5, which becomes negative 0.2. And remember, we've got to move that decimal over 2 places or multiply it by 100. Right? So that will be 20%. And we still have the minus sign there. But in the last step, all we're going to say is a 20% decrease. Okay, they are taking a 20% markdown or a 20% loss when they go to do that problem. When we did that problem. Okay, this next problem is actually really kind of tricky. So make sure. Oh no, I'm sorry. I'm one ahead. So a couple ahead. All right, Melissa's going to buy a house, and we're going to be looking at this a lot later on in this chapter. And a 20% down payment is what banks will typically require of you if you don't want to have to pay a penalty. That penalty is in the form of PMI, or private mortgage insurance. So if you can pay 20% of as a down payment, you definitely should. The problem is that 20% of $287,000 is a lot of money. Okay, so here's what we got. If let's let X be Melissa's down payment. That's what she's going to ultimately pay. 20% of the selling price. Now, in math, the word of pretty much always means multiply, right? Of means multiply. We're going to be using that a lot. If you haven't learned that yet from your previous multiply. If you haven't learned that from your previous math classes, you really need to. Okay, so X equals 20%. I'm going to make that into a decimal as 0.20 times, that's of, and then the selling price. Let's see, Melissa wants to buy a house for $287,000. That must go right there, $287,000. So all I've got now is 0.20 times 287,000. Go ahead and put that in your calculator, and what you'll get is that X equals 57,400. Not good enough. $57,400. Now we have an answer. Okay, X is Melissa's down payment. If Melissa wants to buy a $287,000 house, she needs to come up with $57,000 as a down payment if she doesn't want to pay PMI. Okay. So there's other options, but we'll explore those later on. Bottom line, if you can get 20%, you definitely should. In 2006, the U.S. Chess Federation had about 84,000 members, and 11,000 of these were youth members. What percent of the U.S. Chess Federation were youth? So notice that this doesn't it doesn't ask for what's the percent change. Nothing is changing. It just strictly says what percent of USCF members were youth. Okay. Now, there's a couple ways to think about this. One way is to think back way back at the very beginning when we talked about our Yahoo question of the week about being old, right? We would just take the total, like what we want, divided by the total amount. And that'll work. What we want is the 11,000 youth members, and we'll divide that by the 84,000 people that are in there. When you do that, you get about 0.130952. But that's not super important to be that picky, to be that precise. So we'll move the decimal over 2 places, and I get 13.09. And that's fine. Let's call it 13.09%, or you could say 13.1%. You could even say about 13%. That's just fine. So that's one way to do it. The other way to do this is to change this into an English sentence into a math equation. And a lot of people don't like this as much, but when you get good at it, it makes many other word problems much easier. So, what percent? Well, if it says what, that's something I don't know, and I will call it X. Of, what did we say of means? Of means multiply. Of USCF members. Well, it tells me right here that the USCF had 84,000 members. So I'd put 84,000 in right there for the USCF members. Were. Now this is the one that a lot of people have a hard time with. Were, are, is, they all translate to an equal sign. And now, of course, there's exceptions how people can phrase things, but for the most part, anytime you see any of these words, that's going to be an equal sign. So I'm going to change this were, I'm going to change this into equals. And then youth members. Well, it tells me there were 11,000 youth members. So I'll go ahead and put that there. Now, if I want to try to solve this for x, all I would do is end up dividing by 84,000. And you can see I'm right back where I was a second ago. Right? 11,000 divided by 84,000. And you're still going to get the same answer. You'll still get this 13.1%. And you might say, man, that's so much more work. It's really not. What percent, that's X, of, that means multiply, USCF members, okay, 84,000, are youth members, right, equals 11, okay. Like it's a very simple, with practice it becomes very simple to just set that up. All right. Okay, this was the one that I was thinking of earlier. This one's actually kind of tricky. Go ahead and give it a go. If you can change this from an English equation into a math equation, then you're pretty good. Okay. So give it a shot. See what you can come up with. This, or about 31% of India's population, is younger than 15 years old. What's the approximate population of India? Well, I can think of it by saying 31% of total population is, that's equals that 337,567,000. Right? 31% of the total population is 337 million. I know that because it says 337 million, or about 31% of India's population. Right? So 31% of I'm sorry. I had a little mistake here, this comma, and it was kind of throwing me off here. So about 31% of India's population, like, it is that. Okay, so if we're trying to figure out the population of India, I could say 31% of, that means times, the I don't know, that's the X, equals 337,567,000. And then 31%, I'm going to change that into a decimal and call it 0.31. Now, if I'm trying to isolate X, I would divide both sides by 0.31. It's going to make this number much bigger, but that's to be expected. We get 1088925,806. Wow, that's a huge population, and it's even bigger than that now. Okay, so this kind of makes sense, right? 31%, that's about a third. So if this much is a third, and if you take it times 3, you're going to get up a little over 1 billion. All right, last couple problems here to look at, and this is just kind of something just interesting, because if you can see patterns and if you can figure out human psychology and what's happening in the world, you actually stand a good chance of making some money in the stock market. You also stand a good chance of losing a lot of money, so I wouldn't, don't think of it as like gambling. But it's a fun little hobby. You can make some money yourself. And if you're not interested, then I still strongly urge you to save money and let someone else invest it for you. Find a good 401k. A lot of employers work with people. I know at the school that I work with, they have some financial investors that show up, and they have companies, and you just give them money and they invest it for you. They do okay. But I also like to do my own because it's fun. So this is super interesting to me. If you look back in history, on October 31st, Halloween, not super important, there's a company that you probably never heard of called Cenex or Century Aluminum, and then this is the symbol that they use on Wall Street. Okay, so pretty much every company has 2, 3, or 4-letter symbols that you can type in and find out all kinds of information about them. So the company was valued at $7.31 per share. So you can invest in the company, you can buy some shares of stock, you can do it through a bank, you can do it through many online trading platforms. I personally use TD Ameritrade, non-sponsored. They haven't given me any money for that, so they get some free advertising, I guess. On January 31st, the company was valued at $15.40. Ooh, that's pretty good, right? They went from $7.31 in October to just a few months later, basically the next quarter, they were up at $15. Now, over the same time period, Netflix was $124, and they went up to $140. I remember buying Netflix when it was like $27 a share, by the way. I sold it a long time ago. I don't still have it, but yeah, that's because I'm old. Over the same time period, over those 3 months, we had Netflix go from 124 to 140. Now, I want you guys to figure out which stock was the better investment. Pause the video, find the percent change. Okay? Do it. All right, let's go on and see our answers here. So here's what happened. During this time period, Cenex had a 111 or 110% increase. That's huge. Netflix had a 12% increase, 12.7% over that quarter. That's actually a huge increase as well. Like if you could find a company that was gaining 12% per quarter, even if they just maintain that for a few years, and you invested in them, you would make a ton of money. So this alone, this is a huge gain, but it pales in comparison to this. And the reason I bring this up is I want you to go back and look at this time period. Figure out why a company like this had such a massive gain. Okay? So pause the video, and then I'm going to tell you kind of what happened. But really think about it for a second. Please do pause. Give it a little consideration. Okay, so what you have to think about is what was going on in the world right during this time. October 2016. 2016, that's a year that's divisible by 4. That means it's an election year. Okay? And at the time, Hillary was running away in the polls. All the news outlets were saying Hillary is going to have a landslide victory. And so during this time, a lot of stocks that might benefit if Hillary was in office, their shares were rising during this time. But in November, we had the election. November of 2016, we had the election. Hillary did not win. That became a case study in how some of these predictive statistics and how polling was done so poorly during that, and people study that now. But what did happen was President Donald Trump at the time Donald Trump became the president-elect, and then Century Aluminum is just a raw materials company. And you might say, well, okay, so what? Big deal. Trump ran on the platform of, I'm going to build a wall and I'm going to do infrastructure. We're going to get new roads, new airports, new harbors. We're going to do lots of construction. And so because because Trump was going to be in office, everyone thought that this company, Century Aluminum, was going to get lots and lots of business. And that's why the company doubled over this very short time period. They had a 110% increase. If you had invested $1,000 on October 31st in CNEX, then just a few months later, that $1,000 would actually be worth $2,100. And if you invested $1,000 in Netflix, that $1,000 would be worth $1,127. That's still really good. But I just bring this up because if you can spot some trends in the world, if you can get ahead of the curve and have an idea where things are going, and it's very hard to do. But look for a way to monetize it. Look for a way that you can maybe invest and turn a hobby into something that might help you in retirement. I don't know, it's just interesting. And right now is, of course, a super interesting time in the world. It's very scary for a lot of people, but following the stock market right now is something that a lot of people should do. Just watch a little bit of it and see what's going on, because it's very fascinating right now. Anyways, this has all been about percentages, changing percents, and solving for percents and percent increase, and we're going to be doing a ton of it this chapter. I hope this helped out a little bit.